Hello learners, thank you for joining us today. We will continue with our discussion on risk and return, and we've made some progress under this topic. It is my hope that you are learning and that these lessons will go a long way in not only helping you pass your exams, but you will also be able to apply some of the theories, some of the principles that we are learning under the topic of investment. For example, in our previous lessons, we have made mention of the fact that if you have money and you want to invest your money, if you are working and you have income and you want to invest, we did say that there are two major categories of investments. Either you invest in the economic assets or the financial assets. If you invest in the financial assets, which comprise assets like shares, bonds, stocks, treasury bills, treasury notes, commercial paper, name them, those are financial assets, you are likely to get returns, return on investment. You can also choose to invest in physical assets, real assets, economic assets, capital goods. They are also known as capital goods. They comprise assets like buildings, motor vehicles, plants, animals. You can even buy, for example, animal like a cow. You can buy such physical assets. And you say that these physical assets or capital goods are used in the production of other goods and services. So broadly speaking, that's how we generate wealth. So we are learning all these principles not only for exams, but you will also be knowledgeable. Recently, I saw someone on national television telling people that if they put money in an envelope, money like these notes, that if you put 10,000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this is my money. I worked and I was paid this 10,000. So the individual was telling people that if you are to put, for example, this 10,000 in an envelope, that the 10,000 will yield 100 times in a week, 100 times in a week, meaning that after 1 week, the 10,000 will grow 100 times, meaning this would equal 1 million. Okay? That if you are to put 10,000 in an envelope, after 1 week, the 10,000 will grow to 1 million Kenya shillings. All right? And I thought that is a lie. It is a lie because investments, when you invest money, there is time, okay, that elapses between when you invest the money and when you actually get a return. If you are to invest this money in equity shares, for example, you need to wait for a period of 12 months before you are paid dividend on that investment. If you are to pay debentures, you are to buy debentures in a company, then you also need to wait for about 1 year before the interest is received from that investment. So the reason why we are learning this is so that you can understand, so that no one tells you, cons you out of your money, no one robs you your money. You will understand some of these principles. If you are to buy land, okay, valued at 10,000, it takes time for land to appreciate in value. It takes time. It takes time. Those are physical assets. And even if you are to invest, I've given an example of the financial assets. Financial assets, e.g. equity share. These are ordinary share capital. If you are to buy ordinary share capital in a company, you have to wait until you receive either the dividend, which is an income, or what is called capital appreciation. Capital appreciation. So you can either invest in fixed assets, in financial assets, or economic assets. So it takes time. So that's what I'm saying. Try to relate what you are learning here with what is happening in real life, so that you are a knowledgeable person, you are able to assist others. Even if you are not interested in becoming wealthy, you be at least knowledgeable, have knowledge, help people, so that people make the right decisions, people move forward. And I've given an example, and an example here. Another example would be the reason why you are learning, at least you are now appreciating that betting, which is prevalent in our era, in our age, or gambling. Betting and gambling should not be confused with investment. Should not be confused with investment. Later on, I'll be talking a bit about gambling and speculation, and how they differ from investment. How they differ from investment. So that is an important point right there. As you study, get knowledge, be knowledgeable. Okay? So today we proceed from where we stopped. Last time we were talking about measurement of risk, and we say that standard deviation is used to measure risk. Standard deviation is used to measure risk. Our topic is risk and return. Risk and return. So we continue by looking at more illustrations. Today we want to consider an illustration on how to calculate risk. Okay, risk. And we will use, first of all, our today's illustration, we are going to use past data. The first illustration will be in relation to past data. We want to use past data for two companies and see how we can calculate risk. So we can take an example of past data for 4 years on two securities. You can write here illustration. The past data for 4 years, the past data for 4 years on two securities, A and B, two securities A and B, show that the yield show that the yield or let's say the yield or the yielded, show the yielded return, show that the yielded return on investment as under. So the past data for 4 years on two securities A and B. Securities can be equity share, can be stock, can be a bond. Show that the yield return on investment as under. So we can have here a column for the year. These are 4 years. You can say from, say, 2013 to 2014, 2014 to 2015, 2015 to 2016, 2016 to 2017. These are the years. Then the return for security, the yield or return for security A to be, say, 15%, B the next year, say, 5%, next year 18%, following year 7%. The return security B, return for security B, we can put it first year 9%, second year 11%, third year 15%, fourth year 10%. So we are required to compute or calculate the average, return, calculate the average return offered by the two securities and their relative riskiness You have to compute the average return and the relative riskiness. So this is past data, okay, for two, is historical data for two securities as shown in the two columns. So we are expected to calculate, number one, the average return. Average return for security A will be equal to the total return, okay, over the number of years, will be equal to the total return cumulatively over total return over the number of years. That will give us the average. That will give us the average return. The average return. So the total here will be 15% plus 5% plus 18% plus 7% divided by 4 years. That will give us a return as a percentage. So we take the 15, add 5, add 18, add 7. So this divide by 4. So 20 plus 18 plus 7 divided by 4. So the average return is 11.25% for security A. Then the average return for security B will be equal to the 9% plus 11% plus 15% plus 10% over 4. This will be equal to 20 plus 15 plus 10 divided by 4. So the average return for the two securities to 11.25%. So both securities yield an average return of 11.25%. These are similar returns, a similar return for the two investments. So with the similar returns, with the two securities offering similar return, it's not easy to know which of the two is riskier than the other. Okay, so that's why we need to compute sorry, that's why we need to compute their relative riskness. We need to compute the risk for security A and security B. And how do you compute risk? We compute risk by calculating the standard deviation, for both the securities, So we come here, part B of the question. We start with security A, and we'll have the year, column for the years, This is security A, column for the years. So we have 20, 13 to 20, 14, 20, 14 to 20, 15, 20, 15 to 20, 16, 20, 16 to 20, 17. So then we have the, let me use red pen here. The next column is the returns. The returns as shown in the question, that is 15%, 5%, 18%, and 7%. After the return, then we have the average return. This was the actual return. Then we'll have the average return. The average return here. Average return. The average return. Average return. And the average return here is the average return is 11.25, 11.25, 11.25, 11.25, 11.25. So this is the average return A bar. Okay, you can use that bar. So the average return, instead of using A bar, you can use X bar. to be consistent with the previous illustration. X bar, that will be the average, then the actual is X. Then we can come here and determine the deviations. The deviation would be X, the actual, minus the expected. Actual minus the expected. So these are the deviations. So I take my calculator and get the difference between X and X bar, which is 15 minus 11, 15 minus 11.25, 3.75, 3.75. Next is 5 minus 11.25, 11.25 is negative 6.25. Next we have 18 minus 11.25, 6.75. Then lastly 7 minus 11.25 is negative 4.25. So next we'll have to do away with the signs by getting the square of the deviations. So we need to square these deviations. Okay, we square. Get the square of 3.75 square. 3.75 square. This is equal to 14.06. Next, 6.25 square, 39.06. Next, 6.75 square, 45.56. Next is negative 4.25. Square it, 18.06. These are the squares. So this is security A. We can move on to security B and do the same. Security B here. We continue with security B here. So security B, the years will remain, the return is different. So security B return for security B, the return here for security B, return security B 9, 11, 15, 10, that's the return. Then return X, then there is the average return X bar is 11.25, 11.25, 11.25, 11.25. The deviation here, X minus X bar, the average, the deviation, we take the 9, this one, X, minus 11.25, this is equal to negative 2.25. Then next, 11 minus 11.25, this is equal to negative 0.25. Next we have 15 minus 11.25 is equal to 3.75. Then 10 minus 11.25 is 1.25. So you can go ahead and square the deviations. Square the deviation, this square. 2.25 square is 5.06. Next, 0.25 square, 0.06. Next, 3.75 square, 14.06. And lastly, 1.25 square is equal to 1.56. These are the deviations. So next step is to get the total here, total of the deviations, the total of the deviations squared, this total, we square, we get the totals, starting with security A, 14.06 plus 39.06 plus 45.56 plus 18.06, 116.74. Next total here is 5.06 plus 0.06 plus 14.06 plus 1.56. This is equal to 20.74. So these are the totals. So this is, continue that line there, and this one. So this is the deviations. Deviations are squared. This is the summation. Summation. Let me start with this. This is the summation. The summation of the deviation of XA minus XA, summation security A. Okay, the summation of the deviation of the actual and the average. This is the actual returns for security A. This is the average return for security A. The same thing here. We have the summation of XB minus XB, but that is the mean or the average. This is the summation. So the question is requiring us to calculate the standard deviation. Standard deviation, which is abbreviated as sigma. Okay, sigma. So the standard deviation sigma of security A would be equal to the square root of the summation of XA minus X bar A over N, which is the number of years. In this case, it's equal to 116.74 116.74 divide by 4. That will give us the standard deviation for security A. Then the standard deviation for security B will be the same, which is the summation of x b minus summation of x bar b over n, and this would be equal to the 20.74, the square root of 20.74 divided by 4. That will give us the standard deviation for the two securities. So we first divide 116.74 divide by 4. The square root is 5.4. 5.4 is the standard deviation for security A. Going to security B, 20.74 divided by 4 square root is 2.28. 2.28. So these are the standard deviations for the two securities A and B. A and B, and that was the question. The question was, as you can see from the board here, the question reads, compute or calculate the average return offered by the two securities and their relative riskness. And their relative riskness. So now, since the standard deviations of securities from A and B is more than the standard deviation of security B, since the standard deviation of returns from security A is more than the standard deviation of returns from security B, it indicates that security A, this one here, is more than this. Then it means that security A, our conclusion here, security A is more risky than security B because the standard deviation of security A is greater than the standard deviation of security B. So that's how standard deviation is calculated. So it's a very simple process. In this illustration, we have used past data. The past data for the two securities were collected for prior years. You can see 2013 to 2017, 4 years. It is very easy to calculate for past data because these returns are known. These are actual returns. These are returns that were paid to the holders of these securities. In our next illustration, we'll be looking at a situation where the returns are not known. Expected return. This was to help you understand how to calculate standard deviation, and it's a continuation from our last lesson where we introduced the calculation, how to calculate standard deviation and riskiness of securities. Thank you for attending this lesson. God bless you.
Thank you for watching this video. Don't forget to get yourself a copy of our professionally prepared study text and revision partners. Visit our shop along Tom Mboya Street, Pioneer House, 3rd floor, opposite Fire Station.